Okay, so today we're doing a little bit of review for the test. And some of the concepts were difficult, like not the inverse of functions, but what was that thing we did yesterday? Yeah, flipping, well, it's 1 over something. What's the official name for 1 over something? It's reciprocal. Yeah, reciprocal functions, that's pretty tough. We'll practice that. But some are easy, like this. This is an equation, which I've sketched, and it's this red equation. It's an upside down absolute value. And you have to know how to graph. And that's something that you just expected to know how to do, even though it's not really this chapter. You can't just like forget all the things you learned before. And when the blue zone there, it's decreasing, which you could say it's decreasing from 4 to infinity. How about the green zone? Raise your hand if you can tell me this little part. I'll make it red now. That little part. How would you describe that part? Yes, sir. Mm-hmm. Negative infinity to 4 is correct. Oops, I wrote the wrong thing. I said it right. Negative infinity to 4. All right. How about that spot right there? What do you think the name for that is? It's maximum. Is it also the absolute maximum of this function? Yes, it is the max. All right. Is there such a thing as a max that's not the max? Yeah. There's a function. It's got 2 maximums. But that one's the absolute max, or just called the maximum. This one's not the maximum, but it's called a local maximum. Okay. All right, next thing. Even rule. There's a little function, something over here equals something over here, that's the even rule. If something's going to be even, then it has to follow this. Try to write it down. If you're like, don't even remember what you're talking about, it has f of something in it. F of something equals f of something else. The research shows that if I make you try to recall it, it'll stick better when I actually tell you. The even rule. How many of you knew to start with f of negative x? Raise your hand if you remembered that. That's about half the class. And then if f of negative x is how you start for the even rule, obviously you better stick negative x into the function and see if it comes out to equal what? F of x. Good. That's the even rule. If that happens, if you stick negative x into the function and it comes out the same as it did before, then it would look like this. Like a seagull. There, that's better. Okay, that one has y-axis symmetry, and so it's called an even function. And so if I had the point, let's say 3, 8 on it, do you agree that there would have to be a point over here that goes with it that's, well, negative of the x, comma, same y? That's what this means. If I have x or negative x, I'll come out with the same f of x. Does that make sense to you? Okay, that's the even function. All right, so then how do you prove something's even? I could tell you that this thing is even, but there's telling you and sketching it, and that's still not a proof. Prove using this that this is an even function. And I'm going to change the y to f of x right off the bat. Pause, we give that a try. Okay, in case you forgot, you stick in negative x, and then that'll be empty spot where the x was. That's what you always do, put a parentheses, because do parentheses matter? Yeah, they totally do. Remember that if you had 2 without the parentheses, or with it, this would have a totally different answer than that would. So you've got to remember that f of x, if you replace the entire function, you'd have a parenthesis around where the function was. If you replace an x, like this x right here, this x has to be replaced with a parenthesis in which you drop negative x. Final answer, f of negative x is equal to 6x squared, which is what it was in the first place. So what does that say? F of x is equal to negative f of x. And therefore, 3 dots in a triangle. Therefore, even. There, that's a proof. And one last thing. If you haven't written this anywhere else, this is where you'd write it. F of negative x was equal to f of x. If this does not appear on your test, you did not do a proof. You just did an equation that didn't really prove anything. You've got to have the statement. Okay, so that's the even statement. Here, what's the odd one? Hint, starts the same. Well, it's got negatives on both sides. That's odd. Yeah, it's the odd rule. Okay, let's see if you can do one. Prove if this is or is not an odd function. 1/16 x to the third. Prove that it's odd, prove that it's even, or if you've proved it isn't either one, then you've proved it's neither. Can I replace y with f of x? Yeah, they're the same thing. I'm going to pause for a second. We try proving that this is either odd or even or neither. So we got a little math behind it there about robots and robotics and how that's going to change our world going forward. But I'm going to, just if you're interested in that, you can go to my website and look at the math behind it page. All right, this is odd, and I can prove it. I start with f of negative x. And you might be saying to yourself, isn't that what you do in the even test? Yeah, but do you get if the odd test has f of negative x in it, I have to do it for the odd test anyway. I may as well start with f of negative x. And then this simplifies down to negative 1/16 x to the third. Raise your hand if you got that far. Okay, some of you aren't looking. I don't know what you're doing. Did you two guys look up and did you follow this to here? All right. So those aren't just rhetorical questions. I need you to stay with me. Now I'm going to say, is f of negative x really equal to f of x? Because that's the proof statement about even. Why am I doing even? Well, you may as well check. You're already this far. Because if it is even, do you get it's done? It's over with? Okay. But it's not, because that is not f of x. And therefore, this is not even. Then we factor out a negative 1. So f of negative x is equal to negative 1 comes out, and I'm doing this right here, 1/16 x to the third. And then now I rewrite the odd rule. Is f of negative x equal to negative 1 times f of x? That's the odd rule right there. I just happen to throw a negative 1 in front of it. And that's true as long as that's actually f of x. And is it? Look back to the beginning. Isn't that f of x? Aren't these equal? Yes, they are. And therefore, odd. That is exactly what you'd need to show to prove to me that this is not odd. I could have lived without this part. You could have skipped that line right there, because if you're proving that it's odd, you don't have to prove that it's not even. But you're kind of on the way. It's like you're already that far. You might as well just show it's not even. Okay. Do you want more practice on proving odd, even? Okay. If anybody wants, then in the open time at the end when I say, okay, now you can ask questions, you can always add one then and say, hey, can you show me another proof, or have us do another proof. Okay, next I want to talk about absolute values. Let's say I had a little, that function right there. Would you make for me what this would be? The kind where just the x is absolute valued? Think about it. The x's that were negative now are being changed with an absolute value. Okay, in case you forgot how this one works, It's the x's that are negative, which are these. And those go away because you just absolute valued them. So those are gone. Now, oftentimes the confusion is, what do you do in their place? Well, when I put in like -2 over here, it thinks I put in +2. And so it's going to give me the same result. If I put in like -4 over here, it thinks I put in +4. So it's going to give me the same result. You see how I'm slowly just copying over the stuff from the right? All right, so let's see if I can do this right. There. You have to do it point by point. But generally kind of looks like a W. Raise your hand if you had that one right. Okay, good. All right, so now there's this guy. It's an upside down V shape. That's an absolute value problem, right? Okay, and I want you to make it, if that's f of x, tell me what absolute value around the outside of f of x is. Again, this is f of x. Sketch for me what it would look like to do the other kind. Okay, should be a pretty easy one. The stuff that has negative y's, because remember that's y. The negative y stuff, that's this, is now gone, and it's not just gone. It's been changed. It was made positive. All the y's now, whatever they were, like if this was -8, it's now +8. So they have been reflected up like this. So final answer, that part stays the same, and then it would be like that. So it's basically like a big W. Raise your hand if you had that one right. Okay, good. Now let's do the kind where it's 1 over. So here's part of a parabola. That parabola is not going forever. It just goes from here to here. Now here's my question. If that's f of x, then what's 1 over f of x? Not its inverse. What's that called again? Reciprocal. Draw the reciprocal. Now you could do this by labeling like 17 points on here. And saying, okay, I think this is going to be like -3, -2, and this is going to be 0, 0, and this is going to be 1, -5. You could label a whole bunch of points, and I want you to get what you would do if you did that. Let's say I picked that spot to be -1, sorry, that's 1, 1, -3. On my original function, I have 1, -3. What would my new function be? Which part changes on these reciprocal functions? The x's or the y's? Come on, which part changes? The y's. Because look, all their y's change to 1 over. So this y is no longer going to be here. I'm going to have y new, y prime, and it's not going to be -3 anymore. It's going to be (1 over -3) or -1/3. So if I just want to know where that point right there is going to go, I can say it's going to be at 1, -1/3. That's like here. Well, that alone doesn't help me a ton. What's another feature of these graphs that it's a big deal? Well, the places where the function is 0. Yes, you could say it's the zeros. That spot. Because on the new function, what's going to happen there? Yes, asymptotes. So you needed asymptotes. How many of you have asymptotes running there and there on your graph? Okay, good. And then How about the spots where it's 1? Why is 1 such a big deal? Because 1 over 1 stays the same. So I got to find out the spots where it's 1. I don't know what you picked was 1. Maybe you picked a couple spots like this was 1. And maybe this spot right here is 1. And this spot over here is 1. But 1s are a big thing. Put them on your graph for sure. Then your final answer is this will go through those and get closer and closer to the asymptote lines. It'll never cross there. Because why? Because a positive y, that spot right there, let's say it's at -3 comma positive 1. When you flip a positive number, is it ever going to turn negative? No, so it can't. So it can't go across that line. So it's almost like there's another asymptote in this line here. It acts like an asymptote. All right, 12-minute warning. So there's one part of it. Remember, this acts like an asymptote. This is an asymptote. That should tell you if it's going to get closer and closer to that, then it's going to have to go something like that. Notice it went through the spot where 1 was. Once again, this is going to have to go through this spot. And if you struggle with the tag ends like this, I get it. I get it. Sometimes I look at them and I'm like, I'm not sure where to go on this. I'm not sure where to draw it. Well, I know it has to go through this. That helps. And I know it has to get closer and closer to the asymptote. But you can always make up another point on it. Like I'm going to say that if this was at -1, that's at like a half. So let's say it's over -7 comma down a half. Do you get then when I flip it, 1 over it, that flips and becomes -2? So it's the same distance over, but it's down 2. So it would be like down here. And then I can go, oh yeah, it's going to go like that. If you have to, make a whole bunch of points and change their y values to 1 over what they were. That's how you can be sure. I think this is the hardest thing, so I'm going to give you one more like that. Let's see if you get this one right. Try the reciprocal of that. I'll pause, we give that a try. Okay, here's how fast it can be. That hits 0, asymptote, hit 0, asymptote, 0, asymptote. Where's it 1? I'm going to say it hits 1 here, and here, and here, and here. Now, if it's labeled on the test, you'll have to go with wherever they say 1 is. Okay. All right, so then I'm going to say, well, remember, it can't cross across here, so it's like there's an asymptote going across there, too. There isn't, but it's like there is. So then this has to go down, and it can't go across that line. And then it's going to go back up again, closer and closer to the asymptotes. Same deal here. And I'm going to check and make sure I did the whole graph. Yeah, there wasn't any tag end. Let's say there was a tag end right there. Just imagine there was a little tag end sticking up here. Then I'm going to do it in green, just like the rest of it. Let's say it hits at 1 here. What does really small on my original function mean? 1 over really small. Have you figured this out yet? If it's like 1/100th and I do 1 over that, it gets really big. So it's up here. There we go. Any questions about that? So straight up from this point that I said might have been like 1/100th, straight up from there would have to be 100. So it'd be way, way, way up there. That just shows you which direction to draw the line. Okay, there's so much more. Next topic. That covers yesterday and the day before, and it covers even odds, which is kind of what we started with. There was a little section that was about, like, let's say this is the x and the y-axis. It was like review from honors higher algebra. Do you remember that these spots are important? The spots where it touches. What are those called again? It's 4 names, actually. Nope, those are not asymptotes. These are called the zeros. Now, what you're thinking about is if I was going to find its reciprocal, there would be asymptotes running this way. That's not what we're doing right now. It's just, what are these called? Those are called zeros. What's this spot called? The y-intercept. Okay. And next, what if they said, hey, by the way, f of x is 3. What the heck would that mean? Y is 3. If y is 3, can you imagine that might be a line that runs like this? Do you get that would have two different answers? And it would be, let's say that that hits at -1 and it hits again at like -5. It could have two answers. F of -1 is 3 and f of -5 is 3. As long as you get that f of x is telling you y, because f of x means y. Let me say that. It's like saying y equals 3. It's a line that runs that way. Question? Thought I saw a hand for a second. Okay. So now let's go back to this original starting graph here. I'll just get this out of the way and say, what if I said f of 2? Where the heck would that be? Would you agree f of 2? 2 is in this neighborhood-ish. And if I run through it, it's somewhere like down there-ish. Okay. All right. And now when I give you the x. All right. What if I said, I'm going to tell you the low spot here. Let's say that that spot right there is the low spot in the line, and it's at 2, -1. And then the high spot here, let's say that's at -2, 5. How would you describe this little interval? What is it doing in there? Decreasing. Write me the interval over which it's decreasing. I know we did it before, but we really didn't have many homework problems like this. We only had one page full. It's one of the things that makes honors hard. In regular pre-calc, there's usually like 2 whole days on a major concept. In here, it's like, oh, half of a day we spent on this one thing, and now all of a sudden I have to know that. Again, I can remind you on a review day for the test, but watching review videos is another good way to go because I have them. In fact, you have 2 takes on it. If you're not getting how I explained it, you get that there's often videos that I link of Mr. Ludvigson's classes. If you haven't noticed them, they're there. So you can watch those too. They're right in Schoology. Mine you can find at davidserver.com. Just click a few things to get to the videos and see what I recorded each day. All right. You should have said from -2 to 2. That's like saying from here to here is when it was decreasing. And I don't care if it's parentheses or brackets. Doesn't matter to me. You can use either one because it's decreasing the whole time. Okay. And does this function, again, assume for a moment it ends right here and it ends right here. Does this function have a maximum? What is it? -2,5 is kind of right, but that's not the actual maximum. It's the place where the maximum happened. What is the max of this function? The highest it goes. The 5. Because the actual max is about the height. Now, I would agree, if you had said -2, 5, I'd have been okay with that. But if it just said, what is the maximum, as opposed to where is the maximum, the maximum number would be 5. Okay, does this thing have a minimum? Well, it's a little vague. It's hard to tell if that's lower than this. And so, I don't know. It could have 2 minimums that are the same. Maybe it's like the sine function. In case you don't know this, the sine function runs like this, and it goes back and forth between 1 and -1. And so its maximum is 1, and it happens like 1,000,000 times. Infinite times, actually. Okay. Now I've covered a ton of stuff. Not everything. That's not the way I do this. But Is there anything else you want to ask about? Because it was on the homework, or you just have never really understood it, or you want another practice on this kind, because I keep getting them wrong. Raise your hand if you want me to, you can direct me here, what you want me to lean towards for review problems. Do you remember at the very beginning we had assignments where we would say, hey, we got this, and I wonder where this point on my original function would end up going if I did that to my function. Would you please figure out where 6 comma 8 would go to if I did this to its parent function? I like to think of these in an XY chart. And you do the changes and you'll have X new and Y new. X prime and Y prime. So if it started out at 6 comma 8, this is the stuff that happens to the outside, which is is that the Y's or the X stuff? The Y stuff. So should I just trust it and add 7? Yeah, you trust the stuff on the outside. So 8 plus 7, 15 is your new Y point. Raise your hand if you had that right. Okay, the other one's trickier because you get 2 chances to screw up. Hopefully you're smart enough to know it's not subtract 3, it's actually what? Add 3. And it's not times by 2, it's actually times by a half, or you could say divide by 2. And then the order matters too. What's normally first? Multiply, so you don't do that first. So you start with adding 3. 6 plus 3 makes 9. And then you have 9. And then it seems like you should times it by 2, but in fact, you divide it by 2. So 9 divided by 2, also known as 4 1/2. Raise your hand if you had that one right. Okay, awesome. Now, I strongly recommend that you review tonight. A lot of you are at B's where you could be at A's, but you're not putting in the effort that you need to get the A. It's your life. But I'm telling you, I just hate to see that when you're like one night of review away from an A. Some of you guys can walk in tomorrow and no extra effort right now and have a B, but you wouldn't have the A. It's your choice. There's videos there. There's practice problems we never did there. There's Mr. Ludvigson's videos there. There's lots of options. And tomorrow's a Wednesday, so you could come in for math if there's a topic you really want to work on with me. Okay? All right. That's all I got for you for today. Make sure you study. Test us tomorrow.